Okay, girls, this is a continuation of the video on Wednesday, the 24th of June. Okay, we were on page 17 looking at question 3, and we had to prove that the opposite sides and that the opposite angles of a parallelogram are equal. And we said to be able to do this, even though they don't tell you, to prove that the two triangles are congruent, those two triangles that you can see, you still need to do that. And once you've proven that the two triangles are congruent, you can then say, well, these are corresponding sides, those are corresponding sides, these are corresponding angles, etc. So if you see something like this, it will involve proving congruent triangles first. So here we go with this first line. First, we need to prove that triangle ABD is congruent to triangle CDB. So our first line of the proof is to identify which triangles we're talking about. So we say in triangle ABD and triangle CDB, we have that BD here is a common side. So I've got the BD equals BD common side. We also, because this is a parallelogram, we're allowed to assume properties of a parallelogram such as opposite sides are parallel. We cannot say, well, opposite sides are equal, because they're asking us to prove that opposite sides are equal. So we can't use that as one of our reasons to help us in the 3 steps of this proof. So the only thing we can use, if they're telling us a parallelogram, because they're saying prove that opposite sides and angles are equal, you can't use that as one of your reasons before you prove that the two triangles are congruent, okay? So the only thing with the parallelogram is that opposite sides are parallel, so we can use that. So we've got, well, let's remember with parallel lines, you can look at things like alternate angles. So I'm going to go, this Z angle here. So angle ABD, if I complete the Z, is equal to angle, so ABD equals angle CDB. And the reason that they're equal is that they are alternate angles. And we can say parallel lines, but instead of saying parallel lines, you need to really state which lines are parallel. It's because AB is parallel to CD, but we also know that AD is parallel to BC. Now, what you do to know which parallel lines we're talking about, it's the two straight lines of the Z that we form. So the two parallel lines of the Z that we form are AB and DC. So we have that these two angles here are alternate and that they're equal because AB is parallel to DC. Now, we also so we've got those, we've got that this side is equal. We're going to need something else. We're not allowed to say opposite sides are equal at all. So let's try for another angle. So now in blue, we've got these two parallel sides AD and BC, and from those we form this alternate angle. Like you can do backward Z's as well. So looking at those bits with the blue arcs, I've got that angle ADB is equal to angle CBD. Reason they are alternate angles, but it's not the same two parallel lines as before. It's because AD is parallel to BC. So when there's more than one set of parallel lines, you have to be specific about which set of parallel lines that you're talking about. And for alternate angles, it'll be the two parallel bits that form the Z when you're doing your alternate, okay? So look what we've got marked. We've got angle, angle, and a side. So therefore, triangle ABD is congruent to triangle. So what we're doing, we're going from blank, red arc, blue arc, ABD. So we go blank, red arc, blue arc. It's congruent to triangle CDB, and the reason we can see we've got angle, angle, side. And that side is between the two marked angles, and so is this side in this triangle. It's between the two marked angles. So we've now got that these two triangles are congruent, which means that they're identical in every aspect. So hence we can say, well, AD equals BC. Reason that they are corresponding or matching sides, so corresponding or matching sides of congruent triangles. But we can also say that AB equals DC, and they are also corresponding sides of congruent triangles. And we can also see that angle DAB is equal to angle So we're going DAB from the blue arc to the blank to the red arc equals angle B, blue, blank, red, BCD. They are corresponding angles of congruent triangles. Now, that proves that both pairs of opposite sides are equal, but we've only proven so far that one pair of opposite angles are equal. So to be able to prove that these other angles at D and B are equal, you'd have to do the question all over again. But instead of putting the diagonal across like that from B to D, you would have to do the diagonal across like this. Okay, so again, I'll just do this very quickly, but I'm not going to write it all down. So to prove that this angle over here is equal to that angle over there, we first proved that triangle ABC. So for the second bit, we'd have to prove that triangle ABC is congruent to triangle, I'll go triangle CDA. So we would do that by stating, remember we cannot say opposite sides are equal or anything like that. You would have alternate angles here. You would also have alternate angles there, which I'll do in red. So alternate there. We've got backward Z here, alternate there. And again, we've got the common side. Okay, so by drawing the parallelogram and doing the diagonal this way, so similarly by joining AC, we can prove that angle ADC is equal to angle ABC by first proving that the two triangles are congruent. And once you've done that, you'll say, well, angle ADC is equal to angle ABC, and the reason again would be corresponding angles of congruent triangles. Okay, so I'm not going to do all that here, but you would just follow those steps again. You do the proof, and then you would do this last step, that angle ADC is equal to angle ABC because they're corresponding angles of congruent triangles. Okay, now for question 4. This is the last question on page 17. Now, we're asked again to prove a property of a quadrilateral, and the question says, prove that if one pair of opposite sides of a quadrilateral are equal, so we can see these are equal, and parallel, so this one pair of opposite sides, so CD and FE we can see are equal and parallel, then the quadrilateral is a parallelogram. So we've got to prove that this is a parallelogram. Now, the definition of a parallelogram is that a parallelogram is a four-sided shape with two pairs of opposite sides that are parallel. So we've got one pair of opposite sides parallel. So if I can prove that CF is parallel to DE, then I have a parallelogram. So to be able to do this, I mean, it does not tell you here to prove that the two triangles are congruent, but we do have to prove that first. So we're going to say, first prove that triangle CDE is congruent to triangle FEC. So let's start. So we identify our triangles in the first step. So in triangle CDE and triangle FEC, what do we know? We know that CE equals CE in that it's a common side. Okay? Remember, we've got a set of parallel lines here where CD is parallel to EF, so we can do our backward Z and do alternate angles. So here's my backward Z. So I can say, well, angle DCE equals angle FEC. Reason, alternate angles. And the two sides that make up the Z are the CD is parallel to FE. Now, they've also told us in the question that CD equals FE, and that was given, okay? Because it tells us one pair of opposite sides of a quadrilateral are equal and parallel, and they've marked those there, okay? So what have we got? We've got side, angle, side. Wait, I better put a double dash here because there's single dashes there. Side, angle, side, side, angle, side. So therefore, triangle CDE, which goes along the single dash side and then along the no dash side. So in the same order, that would be along the single dash side and along the no dash side, it would be triangle EFC. So that's actually written in the wrong way. And the reason is SAS. Now, we've proven that these two triangles are congruent. So we can now start identifying either matching sides or matching angles. We're trying to prove really that FC is parallel to DE, and the best way to do that would be to find some alternate angles that are equal. So looking at these two triangles, I'm going to put a little dot here, and that little dot is opposite the single dash side. So this dot here, the corresponding angle in this second triangle here would be opposite the single dash side. Or I could say, well, this dot is located between the double dash side and the blank side. And this dot here is located between the double dash side and the blank side. So these two red dots are corresponding angles. So I can say, well, angle CED is equal to angle FCE. And the reason is that they are corresponding. When I say corresponding, I mean matching, not corresponding angles. So they are corresponding or matching angles of congruent triangles. But I can say, let me look at these. I know they're matching and they're equal. Sorry, that they're matching, and we know that they're equal because the two triangles are congruent. So therefore that size of this angle is the same as the size of that angle. Because they're equal, but then I look at their position, I say, but if I continue this line here and I continue these along there, I can say, well, wait a sec, they form a Z angle. In other words, they are also alternate. So however, these are alternate angles. Now, because the red dotted angles are alternate, they form a Z, and they happen to be equal, then I've got that alternate angles are equal. So I can therefore say, well, I know now that CF is parallel to DE, in brackets, alternate angles are equal. So I've put them in now. So therefore, I've got that's right. CF is parallel to DE, reason alternate angles are equal. Well, now I can say, well, therefore CDEF is a parallelogram because I've got two pairs of opposite sides are parallel. Okay? And that's the end of page 17. I'm now going to go to some exercises in the Year 9 textbook, and just from exercise 10.9, and just do a couple of those, and that should help you with your homework. Okay, girls, this is exercise 10.9, question 13 from the Year 9 textbook. It says that ABCD is a quadrilateral. So we don't AC and BD bisect each other at E. So that means they cut each other in half at E. So therefore AE equals EC, and we know that BE equals ED. And that's what bisect each other at E means. Now, in the first part of the question, in part A, we have to prove that triangle AED is congruent to triangle CEB. Now, before you start the proof, you can already see, well, we're trying to prove these two triangles here. Okay, so make sure you're clear with that. We can see one side. We've got another side that are equal. So that's our two steps. And try and find the last step. Now, we don't know about any parallel lines or anything, but we can see that we've got vertically opposite angles, those two dots there that I've marked. So we can see that to do part A, we're going to do SAS. So you should have an idea of where you're going before you start the proof, and we can see this now. So we're going to identify the triangles. So in triangle AED and triangle CEB, we know that AE equals CE. Reason. Why does AE equal CE? Is because BD bisects AC. We also know that DE equals BE, and the reason why does that equal that? It's because AC bisects BD. Now you don't want to get those the wrong way around. Why does that equal that? Because it's cut by this line AC. Okay, and we also know that angle AED is equal to angle, so I've gone along the single dash side and then along the double dash side, so to preserve order I'll go angle CEB. Reason, vertically opposite angles. Now please do not write any abbreviations like vert op angles. You need to put the full word. otherwise you will lose marks. The only abbreviations that you can use, as I said in the last video, are angle, equal sign, triangle, okay, and other things like parallel, perpendicular, triangle, things like that, okay. So we've got our three pieces of information, so therefore triangle AED, sorry, is congruent. So I'm going along the single dash side to the point and the double dash side, doing the same thing here. It's congruent to triangle CEB, and we can see the reason for that is SAS. Now I'm going to do part B over here. Now in part B, we have to prove that triangle AEB, this one up here, is congruent to triangle CED. So we're trying to prove this top one and this bottom one. So let's see, we've got in identifying the triangles, in triangle AEB and triangle CED. We know again that AE, so in these two, we know that AE equals CE, and it's the same reason as this. BD bisects AC. Just move this over a bit. We also can see in these two triangles, that one and this one, that BE is equal to DE. And why is that? Because same reason as here, AC bisects BD. And we've also got that this angle here equals that one there. So that's vertically opposite as well. So angle AEB is equal to angle CED, reason vertically opposite angles. So again, we can say, well, therefore, triangle AEB is congruent to triangle CED. And the reason we can see again, we've got SAS. So that's parts A and B. Now, the next part of the question asks us to hence show that ABCD is a parallelogram. Okay, now I actually haven't finished that, so I'm going to do that now. It says prove that these two triangles are congruent, which we've done. Then it says hence show that AB is parallel to DC. Now to do that, we're going to need to show that we've got alternate angles that are equal. So I'm going to do that AB is parallel to DC. If I can draw up some alternate angles, I'm going to do, there's my Z. Well, I can say, well, angle ABD, it's alternate to angle CDB. But I can also look at the position here at this angle here, and I can say, well, this cross here is in between the side with no dashes, or it's opposite the single dash side, and I can say, well, this cross is also opposite the single dash side. I can say, well, this cross here is between the side with no dashes and the double dash side, and this cross here, it's the same position, the side with no dashes and the double dash side. So here I can say, well, angle ABE is equal to angle CDE. And the reason I can say that those two crosses, marking those two angles, are equal is that they are matching or corresponding angles of congruent triangles. But I can also say, but angle ABE, if you look at their positions, is that it's actually alternate to angle CDE. Now, because we're saying that those two crosses are in a position that indicate alternate angles, but we've also said that those two angles indicated by crosses are equal, it means that we've got alternate angles that are equal. Now, alternate angles that are equal only ever happen on parallel lines. So I can say, well, therefore, AB is parallel to DC because our alternate angles that we've just talked about are equal. Now, just show that there. Sorry, that doesn't look very clear. I'll just move that down a bit. So what I'm going to do, so we've got that AB is parallel to DC because alternate angles are equal. Now what I've just realised is that I didn't finish off part A as well. So I've, in part A, had to prove that a triangle AED is congruent to triangle CEB, which we did, but then it said hence show that AD is parallel to BC. So in part B, we proved that AB is parallel to DC. Now we have to prove that AD is parallel to BC. Now again, we've proven that the two triangles are congruent. To prove that AD is parallel to BC, it would have to be by alternate angles. So I'm going to do a Z angle here. I'm going to put a cross there and across here. So doing a similar thing to over here, I can say, well, angle DAE is equal, so in there, is equal to angle BCE, reason matching or corresponding angles of congruent triangles. And then I can just do exactly the same thing as this. Then we can say, but if we look at the positions of angle DAE and angle BCE, we know that those two angles are alternate. So, but angle DAE is alternate to angle BCE. Now, because they're alternate angles and they happen to be equal, we can say, well, therefore, AD is parallel to BC. Reason is that alternate. Sorry, I've come off the page. So AD is parallel to BC because alternate angles are equal. Okay, now that's parts A and B done. Now the next part, so I'll just mark in what we've done. And part C of the question says, hence show that ABCD is a parallelogram. Well, if we look up at the diagram, we've got a four-sided shape with two pairs of opposite sides equal and parallel. So we can say, well, we know that AD is parallel to BC and AB is parallel to DC. Therefore, ABCD is a parallelogram because the definition of a parallelogram is that we've got two pairs of opposite sides are parallel. Okay, and that's the end of question 13. Okay, now this is again another question from exercise 10.9 in the Year 9 textbook. It's actually question 10. Now in this question they say that QRST is a rhombus and that the diagonals intersect at X, and you have to prove that triangles QRX is congruent to triangle SRX and hence show that the diagonals of the rhombus are perpendicular. Now there is no drawing in this question, so we're going to have to do our own drawing. So when they say QRST is a rhombus, you have to do it in that order. You go QRST. You can't go QRT and then ST like that. It has to be in order. QRST. Doesn't matter if it's in clockwise order or anti-clockwise order. It doesn't matter where you start as long as you do them all in order. And that the diagonals intersect at X. Okay, so that's what we've got. Now, you're allowed to make assumptions about what a rhombus is. Now, we know that a rhombus has two pairs of opposite sides. We know that a rhombus actually has four equal sides. We know that opposite sides of a rhombus are parallel. So we can assume any of that. But we're not going to assume anything about the diagonals of the rhombus being perpendicular or anything like that, because we're asked to show that. So you don't go listing all the properties of a rhombus you know. Just keep it very, very basic in that opposite sides are parallel, and that all four sides of the rhombus are equal. Okay, you're not going to say diagonals bisect each other or anything like that yet. We'll just see what we need to say. You can pretty much say anything apart from this. Diagonals of the rhombus are perpendicular. So let's start. We have to prove that triangle QRX is congruent to triangle SRX. Now these two are next to each other. Okay, well, let's just start marking in some basic information about a rhombus in that all four sides are equal. So let's do that. So we're going to start with our answer here. So we go in part A. You have to identify your triangles first. So in triangle QRX and triangle SRX. Well, we know that QR equals SR. Reason, equal sides of rhombus. Okay. Now we're going to have to look for something else. I can see here that we've got a common side, that Rx equals Rx, common side. Now, I'm just thinking we can't really do, we can do some other properties. I mean, there's lots of properties. We just can't use this property here. I mean, we know that diagonals of a rhombus bisect each other. We know that diagonals of a rhombus bisect the angles of the rhombus, so we can use one of these things. We can't really go using alternate, because if I did alternate, that angle up there would match with this one down here. or if I do my Z there, this angle here matches with that, and that's not helpful because we're in two different triangles. So far I've done these bits in red, where I've got side and another side. So we can either do this other side here, or we could do these angles here. Okay, so we'll just look at that in a minute. So for our next reason, I'm going to go with that QX is equal to SX, and the reason is that diagonals of a rhombus bisect each other. Okay, so that means that RT bisects QS in half. All right, so therefore we can say, well, triangle QRX is congruent. Now make sure we're doing it the right way. QRX along the single dash side and the double dash side. So it's congruent to triangle single dash double dash SRX. The reason is SSS. Now I could have done this another way. I could have had the two sides that I had, and I could have said that angle QRX equals angle SRX because diagonals of a rhombus bisect the angles of the rhombus, and I could have done SAS as well. So there is not only just one way of doing this, okay? So we've proven that the two triangles are congruent. Now we've proven all three sides. So we're now going to say, so after we prove that triangles are congruent, our next step is normally to say, well, these are corresponding angles and things like that. So hence we have to show that the diagonals are perpendicular. In other words, we have to show that we've got a right angle here. So if we can show that this is a right angle here and that's one there, then we can say, well, the diagonals cut each other at right angles. So we need to be talking about angle QXR and angle SXR. Now we know that they both are opposite the single dash side in these congruent triangles that we've just proven. So we can say, well, angle QXR is equal to angle SXR, and the reason is that they are corresponding or matching, so corresponding angles of congruent triangles. But we can also say that angle QXR plus angle SXR are equal to 180 degrees, reason angles on a straight line. So we can say, well, therefore, angle QXR is equal to angle SXR. If they're both equal and they add up to 180, then they both must be 180 divided by 2, which is 90 degrees. So we can say, sorry, I've got QXR is equal to angle SXR equals 180 over 2, which is 90 degrees. So I'm going to put those in. And now I can say, well, therefore, we can say that RT is perpendicular. So RT is perpendicular to QS. Therefore, the diagonals of a rhombus bisect each other. And I'll just move this up a bit. Okay. Actually, sorry, girls, it's not diagonals of a rhombus bisect each other. We already knew that before. We're trying to prove that diagonals of a rhombus are perpendicular. In other words, that they meet at 90 degrees, which we've just shown. Sorry about that. So diagonals of a rhombus are perpendicular. Okay, that's the end of question 10 in exercise 10.9. Okay, this is still exercise 10.9, question 9. We are told that WXYZ is a rectangle, and we have to prove that triangle XZY is congruent to triangle XYZ. Now, there's no diagram, so we need to draw it to see what's happening. Now, again, it has to be in order. W, X, Y, Z is a rectangle. Now, we know different properties of a rectangle. We can talk about any properties of the rectangle apart from anything about the diagonals being equal in length. So we can say opposite sides are parallel, opposite sides are equal. We can't say that the diagonals are equal in length. We're not allowed to say that. We're allowed to say that we've got right angles. Okay, so it's asking us, now we haven't got any triangles drawn in here, so we're going to have to draw triangles. So we're just going to see which way we do the diagonal, this way or that way. And we know which way by looking at this. We have to prove that triangle WZY, so WZY, if that's going to be a triangle, I need the diagonal like that. So prove that triangle WZY is congruent to triangle X. Oh, this is congruent to triangle XYZ. So actually I have to draw another triangle across here. So what I've got to do is prove that that triangle there, WZY, is congruent to triangle XYZ. So just be careful because we've got overlapping triangles here. Okay, so we're going to start. Now just be careful, remember these two triangles are overlapping. Okay, now what I like to do sometimes if they're overlapping, I'm just going to draw them separately down here. But we still need to know that I'm still going to keep this diagram up here, but this is this triangle on the left, WZY. I'm going to draw this triangle here on the right, XYZ. Okay, now let's have a look. We're trying to prove that these two triangles are congruent. Well, we can already see, we can say, well, so part A, in triangle WZY and triangle XYZ. Well, we can see we've got a common side, so let's do that first. So we can see that ZY is common. So we can say ZY equals ZY common side. Okay, what else do we know? Remember these two triangles are sitting there, and this angle here is 90 degrees, and so is that. So I'm going to put them down here. See, it's much better to draw them separately. So I'm going to say, well, angle WZY is equal to angle XYZ, which equals 90 degrees, and that's because they are angles of a rectangle are 90 degrees. So angles in a rectangle, they're all 90 degrees. Okay, now we can't say anything about these diagonals, but we can see that this is a rectangle, and we know, for example, that WZ equals XY. So I'm going to mark them in here with double dashes. So now I'm going to say WZ equals XY. And the reason that we know that is that they are opposite sides of rectangle are equal. So I've marked that here, and we can see, yes, we do have right angle, but we don't have the hypotenuse, so we can't say RHS. But what we've got is side angle side. So we can say, therefore, triangle WZY, so WZY, we're going along the double dash side, the right angle single dash side, is congruent to triangle XYZ, and the reason is SAS. Now we're trying to, in part B, to prove that the diagonals of a rectangle are equal in length. And here are the diagonals, WY and XZ. So I can say, well, WY is equal to XZ. The reason that those are equal, I'm going to put triple dashes now, is that they are matching or corresponding sides of congruent triangles. So I can say, well, therefore, they happen to be the diagonals of the rectangle. Therefore, we can see that the diagonals of a rectangle are equal in length. Reason is, of course, that WY and XZ are the diagonals of rectangle WXYZ. Okay? And that's the end of that question. Okay? All right. Okay, now I'm just looking at the rest of exercise 10.9. I would like you to do question 4 and 5, which you can see here. And I'd also like you to do, I'm just moving it up now. Sorry, it's just moving. So we've got 4, 5, having a few problems here. And I want you to do question 6 and 7 I've already done on the worksheet. So questions 4, 5, 6 and 8 and 11. So I'll just write that down for you. So here's the homework. So exercise 10.9 from the Year 9 textbook. Please do question 4, 5, 6, 8 and 11. Now I'm just going to draw diagrams for any of the questions that do not have diagrams. I'll just bring up those questions in a minute. Okay, I've just got some diagrams here. This is the diagram for question 4A. And over here, where we've got triangle PQR and S lies on QR, that this is the diagram for question 5. So I would just do question 4A, question 5, and then questions 6, 8 and 11 from the Year 9 text. Okay, that's the end of this video. The next video will have some questions from the Year 10 textbook.